This is Mr. Precella with this college algebra class, and today we're going to be discussing how to solve nonlinear inequalities using a process called the cutpoint method. And there's going to be a system of steps that we're going to follow. An inequality is a statement that has a less than or a greater than or less than or equal to or greater than or equal to symbol in it. Up to this point we've been solving equations. Those have equal signs. Inequalities have less thans or greater thans. And we're going to draw a number line during this process and shade some intervals. And I want to, before I do anything else, review something you've seen before in another class, in a previous math class, something called interval notation. So I think I'll review that right here. This sequence of steps that I have here, you have under document sharing, so you can, it's already posted there, so I should have already given that to you. So you have that, and I'll be going through those steps in a moment. But first, let's review something called interval notation. We're going to review interval notation. I'm going to start off by drawing a number line. Now I'm going to just plot some numbers on the number line. Okay. Remember, negative numbers to the left. How about this? A negative 7, a negative 2, how about a positive 3, 4, and a 6. Okay. So I'm just drawing a number line and labeling some numbers. And at each of the number lines, let's see, each one of these numbers, which I'm going to call cut points, because they're cutting the number line. Let me use a color that I can see. I'm going to put either a closed circle or an open circle. Close, open, close, closed, closed, open. Now I'm going to shade parts of the number line. Like right here, this pink region that I've just shaded represents all numbers between negative 7 and negative 2. And the closed circle tells you whether the closed circle and open circle tells you whether that number is shaded along with this. And the closed circle means not including the closed circle means including that number. The open circle means you're not including. See, this closed circle is shaded along with the pink. So when you look at this pink interval, you say, okay, that's all numbers between negative 7 and negative 2, not including negative 7, but including negative 2. And suppose we have a purple interval right here. That would be all numbers between 3 and 4, including 3 and including 4. Sometimes students will say, well, that's it, just 3 and 4. No, we're not just talking about integers. We're talking about all the real numbers. Imagine all the decimal numbers in between here. 3.1, 3.2, 3.3, and so forth. And then finally, say all numbers to the right of 6. Now to write interval notation, this is going to be a symbolic way of writing all numbers between negative 7 and negative 2, not including negative 7, but including negative 2. We'd write it like this. use parentheses for infinity symbols, and brackets for use parentheses for open circles and brackets for closed circles. This notation that I've just written here means all numbers between -7 and -2, not including -7, but including -2. Somewhere in your life you've seen this interval notation before. Then the purple interval, to write out symbolically all numbers between 3 and 4, including 3 and including 4, you'd write it like that. And if you get the hang of this, you see, well, it's going to be left, right. So for these the arrows here, you might want to think of those. These are not 8s that I'm drawing. A negative infinity for the left arrow, a positive infinity for the right arrow. This black interval here would be parentheses 6, comma, infinity. Now, parentheses mean that you're not including that number. Infinity, brackets mean you're including it. Well, it wouldn't make sense to talk about including infinity. That would be like saying including the green arrow. So, all numbers between 6 and infinity, not including 6 and not including infinity. And then we'll connect these with what looks like a U-shaped figure, and it's red union. Some of you may have seen that, studied set theory, union and intersection before. Probably all of you have seen it somewhere. For our purposes, it's called a union symbol, could put it between those. So what I have written here is all numbers between -7 and -2, including -2, not including -7. All numbers between 3 and 4, including both 3 and 4. All numbers to the right of 6, not including 6. Well, if you want to say all numbers between 6 and infinity. Okay? Now, if you look at the sequence that we're going to be using to solve our inequalities, this last step here says express the shaded intervals using interval notation. Steps 1, 2, 3, and 4 are going to tell you how to draw the number line as shaded. It's going to tell you how to find these numbers on the number line, which I'm going to call cut points. But by the time you get to step 5, you have the number line drawn, and then you have it shaded, and you just write out the interval notation. So it's sort of helpful to keep in mind what it's going to look like before it's all over. You'll have a number line drawn, and then you'll write out interval notation. So looking through the sequence of steps, and at this point, maybe I should let me find an example that we're going to do. First problem we're going to do is going to be this number 5 right here. Okay, this is an inequality. It has a less than or equal to. And so we're going to go through the sequence of steps. Eventually we're going to draw a number line and plot some numbers. So how do we find those numbers we're going to plot on the number line? That's what these steps are telling you right here. You're going to start off by replacing the inequality symbol with an equals and solve it. Those are going to be called the solution cut points. Replace with an equals and solve. Then you're going to remember that any fraction, you can never have a denominator as 0. So you're going to take any denominators that you have and set them not equal to 0 and solve for x. Those will be called the domain or denominator cut points. So we're going to have solution cut points and denominator or domain cut points, whichever word you want to call them. The third step tells you, okay, draw the number line, and it tells you how to decide between open and closed circles. For the solution cut points, you look up here. If there's an equal sign on it, then close circle. If there's not an equal sign, you'll use an open circle. And that's spelled out on step 3. But for the denominator cut points, you're always going to have an open circle. You'll never want a number over 0. And then to figure out which region you shade, you're going to be taking a number from each interval and substitute it into the original inequality. When you get a true statement, you shade it. That'll be part of the answer. If you get a false statement, either leave it alone or cross it out. See, what I'm saying there is cross it out. And we better just get an example. Another place, this is problem number 5. I'm going to write it down. Let me get my pen. Okay. Oh, well, I guess I don't really need, well, I'll go ahead and rewrite the problem. 2x over x plus 2, it's an x, is less than or equal to 3. Now the first thing you'll do is find what's called the the solution and cut points. And here's one place where, there's another place, I have the steps written out twice in the document sharing. Here where it's typed up, and also just handwritten, outlining it. So find the solution cut points by replacing the inequality symbol with an equals and solving the equation. So let's do that first. I'm going to find the solution cut points. That's step 1. I'm going to write 2x over x plus 2 equals 3. Now I'm going to think of that as 3 over 1. So whenever I have an equation in the form fraction equals fraction, what I'll be doing this semester is just cross multiplying. So we'd have 3x plus 6 equals 2x. And here you're going to get to start seeing my little notation for something like this. In order to solve this for x, I'll put all the x's on one side. And the way I'm going to do that is subtract 2x from both sides and subtract 6 from both sides. So if I'm subtracting 2x and subtracting 6, I'll have x equals, is that 3x minus 2x is just 1x. Subtracting 6 from both sides, just x equal negative 6. Now, look at this step 1 right here. Replace the solution, find the solution cut points by replacing the inequality with equal, solving the equation. Then I'll go ahead and decide right now, is there going to be an open circle or a closed circle? You look up here, and it's a closed circle. Okay. Now, let's do the second step. Find the denominator cut points by saying denominator can't be 0. And those will always have an open circle. Okay? So, let's see. Now, if there's not a denominator, if there were no fractions in the problems, then you wouldn't do step number 2. You wouldn't find any denominator cut points if there weren't any denominators. So I'll use this. 2. Finding DCP. I'll say x plus 2 cannot equal 0. So x can't equal, don't let the fact there's a not equal to scare you. You just solve it the same way you would any other type of equation, linear equation. Just move the 2 over by subtracting 2. And with the denominator cut point, there's always going to be an open circle. And you should be able to convince yourself of that. If you took a -2 and plugged it in here for x, the 2 times -2 would give you a -4. But if you plugged in -2 plus 2 in your calculator, it's going to give you one of those error warnings. The -4 over 2, -2 plus 2. You would have a -4 over 0. So now the next thing we need to do is draw the number line. Those are the numbers you're going to be labeling on the number line. Okay? So let's see. This is step 3. Okay, step 3. Plot the cut points on a number line. So I'm going to draw a number line. Ooh. And on this number line, don't label anything other than these 2 numbers here. And make sure when you do label them that you're labeling them in correct numerical order. Which number would be closer to the negative infinity? Well, -6 with its closed circle would be to the left of -2 with its open. So we plotted the cut points on a number line. Now you're going to test the intervals. By test the intervals, I mean choose a number from each interval and plug it into the original problem. If we get a true statement, we're going to shade it. If we get a false statement, we're going to cross that out. Okay? So here goes. I need to test a number between -infinity and -6. Well, there's a lot of numbers here. -7, -8, -9. So I'm going to be testing -7 here. Then between -6 and -2, there's -3, -4, -5. I guess I'll just use a -3. And then can you imagine all the numbers between -2 and infinity? Let's see, that'd be -1, 0, 1, 2, 3, 4, 5, 6, 7. Whenever possible, I'll usually use 0 because that's usually a pretty easy number to test. And when I say test it, I mean you go back up here to the original problem, and in place of that purple X, I'm going to put that -7. 2 times -7 over -7 plus 2 is less than or equal to 3. Well, the 2 times -7, that would be a -14. -7 plus 2 is -5. No, a negative over negative is positive. What about 14 over 5? Is that less than 3? If I go something like this, 14 divided by 5, 2.8. So we have a 2.8 is less than or equal to 3. True or false? Well, true. So that region here will shade. If you choose any number out here, there was nothing really special about -7. -8, -9, -10, -100, any number in this region will make that original problem true. Wow. Now let's see about this one right here. I'm testing the negative 3. Plugging negative 3 in up here. 2 times negative 3 over negative 3 plus 2 less than or equal to, less than or equal to 3. So I'm plugging negative 3 in here and there. So on top, 2 times negative 3, that would be a negative 6. Negative 3 plus 2 is negative 1. And this is hard to read, but it's that purple 3. Okay. So we have negative 6 over negative 1. That's a positive 6. Less than or equal to 3. That is false, isn't it? So no number between negative 6 and positive 2 would be a solution. Now if you want to guess, the first one started off as true and the next one was false. What do you think you'd probably guess if you had to guess on the next one? Usually these things alternate, not always. And we'll discuss in a little bit how you can sort of look and tell if they're going to alternate. But usually they alternate. Let's see, if I plug a 0 in right now, in this original problem, 2 times 0 over 0 plus 2 less than or equal to 3. So I'm plugging that 0 in. 2 times 0 is 0. 0 plus 2 is 2. 0 divided by 2 is 0. 0 is less than or equal to 3. I'm thinking that's true, isn't it? Okay. So far, first thing we did, find the solution cut points. Then we found the denominator cut points by saying denominator can't be 0. Notice with the denominator cut points, you always have an open circle. With the solution cut points, you look up here in the original problem. Then you plot those numbers on a number line. And then what we just finished doing, you test the intervals. Choose a number from each interval and plug it into the original problem. Now there's only one thing left to do. Write the interval notation for the shaded intervals. Okay, your final answer will be those shaded intervals, not the false or crossed out ones. Okay, it's the true intervals. So here we go, writing it in interval notation. Would be parentheses, negative infinity, comma negative 6, square bracket, union, parentheses, 2 comma infinity. Oh yeah. Okay, sorry there. Okay. And this is called solving a nonlinear inequality. And I say nonlinear. This method would certainly work for any sort of linear inequality in the form ax plus b less than or greater than c. But we'll really solve pretty much any type of inequality, as we'll see before it's all over. Ooh, yeah, I can't get it all fit on there, can I? Okay. Maybe I can do a zoom out. There. Let it resume. There. Okay, it all fit there. So on this one, this was my number 5 that I'd done. You type in the solution set, parentheses, negative infinity, comma, negative 6, bracket, union, parentheses, 2, comma, infinity. Okay. don't put any space, don't hit space keys or anything when you're typing this in, and there'll be a union symbol to the left when you type that in. Okay? Now, maybe right now is a good time to try to justify why do I say things like, okay, for the solution cut point, for the solution cut points, look up here to decide between open and closed circles. Okay, so I'm trying to justify why do I say that. If you're not interested in why, then fast right past this, okay? But a closed circle means you want to include that number as a solution. It makes the statement true. If we took -6 and plugged it in for x, let's do that. Let's see what would happen if I plug a -6 in for x. If I had 2 times -6, that's -12, of course, okay? Divided by, I'm plugging a -6 in for x. We'd have -6 plus 2. So we have -12 divided by, so what I'm doing is I'm plugging -6 in here. And we're going to see, are we getting a true statement or a false statement? If it's a true statement, you should then have that region shaded and it should be, that number shaded and it should be included. So we have -12 divided by -4, which is +3. 3 less than or equal to 3. Is that statement true? It is. Why is it true? Because of the equal sign. If there hadn't been an equal sign there, it'd be 3 less than 3, and that would not be true. So you're not going to include it if there's not an equal sign. Open circle if there's not an equal sign, closed circle if there is. Remember, closed circles mean you're including that number, that it's a true statement. Now what about the denominator cut point? For the denominator cut point, I say you're always going to use an open circle. Well, let's do the same thing we just finished doing. Let's plug -2 in. If we plug -2 in for x, 2 times -2 is -4, divided by -2 plus 2. You see, the -2 plus 2 is going to give you a 0 on the bottom, and you can't divide by 0. You'll get an error warning. -4 divided by 0 is not 0. It's undefined. And so you're not getting a true statement there, so you're never going to want to include the denominator cut points. Well, we're running out of time, but maybe we have time to do one more right now. Let's do problem number 1. Here it says solve the quadratic inequality. Notice this one, there's no denominators. There aren't going to be any denominator cut points. We just go straight to finding the solution cut points and then drawing the number line. So let's solve it as if it were equals. Well, we've already solved quadratic equations, haven't we? We'll do this one by factoring. X and x. This one we can factor pretty fast. 3 and 5 plus 3 and a minus 5. We're still having trouble with factoring. It's been a while. You might want to stop it and pause the video and FOIL this out. Make sure you agree with how I have that factored. And then set each one of these factors to 0. So we get x equals, subtract 3 from both sides, add 5 to both sides. Draw a number line, make sure that you're labeling these numbers in the correct numerical order. And you know, what have I not done? Let me go ahead and decide. Since I'm about to label them, -3 would be to the left of +5. I need to know open or closed circle. Well, you look up here, and it's going to be open. If you actually plug these two numbers in for x, like 25 minus 10 minus 15, if I plug the 5 in, 25 minus 10 minus 15 is 0. 0 greater than 0, that's not true. 0 equals 0. So if there's not an equal sign, you're not going to include those solutions. Now, in general, when you have something factored like this, if there are no repeated factors, then it's going to alternate. Okay? If there are no repeated factors, and by that I mean if we had gotten x plus 3 times x plus 3, if the same factor had appeared more than once, then it might not alternate. But since we're running out of time, I'm going to do this the lazy man's way. Okay, it's going to alternate, no repeated factors. So let's just choose one number to test. And the number that I usually use is 0. So I ask myself, where on this number line does 0 lie? Is it between two negatives? Between a negative and a positive? Or between two positives? Well, 0 is always between a negative and a positive number. So I'm just testing 0 and plugging it in here to the original problem. 0 squared is 0. Minus 2 times 0 is 0. Minus 15 is greater than 0. So let's see, what do we have? On the left, is it just going to be negative 15 and then greater than 0? Is negative 15 bigger than 0? No. Okay? This is a false statement. I think all of us would rather have $0 in our bank account than negative 15. Okay? So 0 is bigger than negative 15, not the other way around. So this is false. And since we're about out of time, since there are no repeated factors here, the other ones, it alternates. If it's false in the middle, beside it, it's trues. So if you want to test, maybe test it to check this, a -4 and a +6 maybe. But we're out of time. So this interval here would be -infinity, comma, -3, parentheses, then a union. Notice I'm using parentheses because it's open circles, parentheses, 5, comma, infinity, parentheses. Now there's a sequence of steps I'm doing here. And you can find those sequence steps under document sharing. It can be written like this. Now this is the formal statement, which is the better one. And this is just my little informal handwritten sequence. Okay? So start working on these nonlinear inequalities, and I'll do more of these the next time. There's the solution. Be sure when you're typing these in, don't put any spaces. Okay? Okay, so we're out of time right now. I'll do some more examples of these the next time, but this is it. Okay? This is how you solve a nonlinear inequality. It's actually a very, very, very nice method. Okay? First time I ever saw this, the method I was using was think about it. Okay? With a teacher, then we just thought about it until we came up with the answers. Okay? So I'll see y'all I won't see y'all. Okay, I'll talk to you later. We'll continue this discussion in a little bit, but we're out of time right now. Thank you. Bye-bye.